Good morning, Year 10. In today's lesson, what we are going to be looking at is covalent bonding. Now, in my lessons, I've talked quite a lot about things called valence electrons. Now, these are electrons that are situated in the outermost shell of an atom. Okay, now, in this, we are looking at something called covalent bonding, which is, the etymology of it is co for cooperates, which means working together, and valence is the outside shell. So it's a working together of the outside shells, or the electrons in the outside shells. So a covalent bond is one in which a pair of electrons is shared between two non-metals. And it's really, really important to remember that. Now, before we go any further, I want to do a little bit of a recap here of some of the key points. Now, in front of you, what you should see now is a copy of the periodic table. Now, along the top of the periodic table here, 1, 2, 3, 4, 5, 6, 7 and 0, those represent something called the group numbers. Now, the group number represents the number of electrons in the outside shell. And because each element in that period has the same number of electrons in the outside shell, what we can do is say that those elements have very similar properties because of that number of electrons. So whenever we are looking on a periodic table and we have to work out how many electrons in the outside shell, we look at the group number. So if we are talking about sulfur, sulfur is in group 6. Its outside shell should have 6 electrons in it. Aluminium is in group 3. It has 3 electrons in its outside shell. Argon, and this is the weird one, is in group 0, which means it has not 0 electrons, but a full outer shell. So that would mean there's either 8 electrons or 2 electrons if it's in this very top row. We say that it's got 0 because we draw a fake outer shell with no electrons in it. That's why it's called group 0. Now, let me talk about that a bit clearer. I'm going to move this off, and what I'm going to do now is talk to you about chlorine. Now, chlorine, Cl, is in group 7. That means if I'm just going to draw the outside shell, I draw a circle. I can put Cl in the middle to identify that it's chlorine. And because it's in group 7, it's got 7 electrons. Now, the way in which I draw those electrons in is very specific. Now, you will see me do this every single time. I'm going to draw these as dots at first. So I'm going to do north, south, east, west. That's 4 electrons. Once I go past those first 4, I then start to pair them up. And I pair them up going clockwise. So I now got north, south, east, west, and I'm now going clockwise. 5, 6, 7. So I've got, technically, because this shell can contain only 8 electrons, I've got an empty space there where an electron can occupy. Okay, now because of this, we come up with the idea that all elements react in order to gain a full outer shell. So this is what we call the valence shell. It's the outer shell. So in this case, chlorine needs 1 electron. Okay, dead simple so far. So if we are doing covalent bonding is where they share a pair of electrons in the outside shell. Now this only occurs between non-metals. Okay, only occurs between non-metals. Now, essentially what happens is this. Move this up slightly. The only way I can get this bond together is, for example, we know that chlorine in its natural state is Cl2. Okay, now the way that this happens is I'm going to draw this, and you will always draw this the same. You draw two circles, and you get them to overlap just the tiniest of bit. So when you're looking at the PowerPoint and the explanation of the PowerPoint later, it tells you about drawing them in overlap. You need to look at the empirical formula, which is this. Then you look at you draw them in and put the CLs into the middle of them. Now I'm going to use two different colours for this, but what they suggest that you do is when you are drawing these, that what you do is use dots and crosses. So I'm going to keep that in the main picture going. Now because they're in group 7, both of them have 7 electrons. So I'm going 1, north, south, so I'm following this one, east, west. In this case, because it's the leftmost one, I'm going to go anti-clockwise this time. So it's 1, 2, 3. So that's 7 electrons. Now the other chlorine will also have 7 electrons. Okay, so we go north, put these as crosses, north, south, east, west. Then we go clockwise around. 1, 2, 3. Now, what you can see now is this area on this piece of paper where, in fact, what is actually happening is where these two overlap, there's this area here, very much like a Venn diagram in maths, where the electrons between the two elements actually are shared. So if I go 1, 2, 3, 4, 5, 6, this overlap area, 7, 8. One dot from its orbit, electron, and a cross from the valence shell of the neighbouring. So it's sharing this bond. If I do the same with this one, 1, 2, 3, 4, 5, 6, 7, and the one it's sharing, 8. So that is essentially what a covalent bond is. Now I'm going to change this around slightly, and I'm now going to give you another covalent molecule. This one is HCl. Now, going back to our periodic table, you find that hydrogen has 1 electron, Cl has 7. Okay, so if I'm going to draw this separately, I'll draw hydrogen. Because it's only got 1 electron, I draw it nice and small, and I'm going to give that a dot. Chlorine, it's going to be as big as our last chlorine. And this time I'm going to draw crosses. So I've got Cl in the middle for chlorine, and I've got north, south, east, west. Then I go clockwise, cross, cross, cross. Now you can see here that hydrogen has 1 electron in its outer shell, so needs a maximum of 2. Chlorine has 7 electrons in its shell, so needs to get to 8. Now, if we are going to join these together, what they do is I'm going to redraw this. And I do apologise, but I've gone off the end of the paper. I'm going to overlap the circles. H goes in there, Cl goes in there. I'm going to put my dot in the bit that joins to the H. Now what I'm going to do is put my crosses in. So I know 7, so I match the diagram above. And I put a cross in that. Now the reason why we use dots and crosses is so that it matches, we can tell where each of the electrons comes from. In this case, because they're both chlorines, we couldn't tell the difference between which one contains which. So this is called a dot cross diagram. One element has dots for its electrons, the other one has crosses for its electrons. Here it's also a dot cross diagram. I put a dot for the hydrogens and I put a cross for the chlorine. So when we look at this, we can see where each one is represented. Now, a step further than this, dead simple. If I was another way of representing that bond is if I write this down, what I do is I would write Cl and I would draw a line and then a Cl. What this actually means is this line represents the pair of shared electrons. Okay, so whenever you see that line, it actually, remember it's an imaginary pair, it's a pair of electrons and we're using the line. So this one would be HCl, like that, but the line represents a pair of electrons.